Thank you for letting me come here to Vilnius and talk to you. It's my first visit to Vilnius. Not my last, I can assure you. Some about me. As you can see here, my name is Hjelmberg. That J in name confuses a lot of nationalities. So, but pronounce it like a Y, Hjelmberg. Consultant at SQS, as you said. Been testing for about 15 years, mainly as a test lead, test manager in the functional test area. And also great fan of board games. So we're going to try to combine those two today. But first, this is about me. Now let's go back to you. What do you do? I mean, obviously since you're here, you have something with testing to do, right? But, okay, a few board games, perfect. But have you tried to explain to a non-tester what you're doing? Like your partner, your kids, your parents, your friends? Is it easy? I mean, my wife is a doctor. When she says, I'm a doctor, no one wonders what that is. They ask questions and continue to tutor. When I say I'm a tester, they, that's it. And if they would ask me more about testing, I mean, okay, we know that what to do, but do we know why we do things? What our goal is? Do we know how we overcome the challenges to get to this goal? Is it easy to answer that question as a tester? Probably not. And if it's a difficult question to answer, how can you ever teach someone else to do testing? And that's what we're going to look into in this presentation. Just first a small kind of everyday image from my life, maybe yours too. What happens when I try to tell someone what I'm doing? We've seen it before, the famous Hjelmberg cartoon. Mom asks for the 10th time, what do I do for a living? Try to tell her that I'm a tester, engineer, whatever. Yeah, you say that, but just go to a lot of meetings. When do you do anything? When do you have time to do anything? Well, I could try to find some different angles to answer the question, maybe say I'm a knowledge worker. And then comes all those other questions that I can't answer, and we just end up confusing each other as usual. Have you been there? Some noddings? Okay, so let's think a bit more about then how we can teach someone what to do. What's our source of knowledge? Are you familiar with this one? Yeah?
Sorry, your mic is a bit too close.
Too close? Thanks. Better?
Probably a bit close.
Somewhere in between? So great to be among testers, thank you. This is from ICQB. I guess all of you know what that is. Someone who doesn't know what it is? Okay. It's a long list of things that you should know as a tester. Let's look at it. Read faster. Learn. Did you learn anything? Maybe not. This is not a very efficient way of learning. It's just words that makes no sense at all whatsoever. This is something that I'm trying to move away from when I teach things, when I teach testing. I want to teach my students not what to do as a tester, but how to think as a tester. The thinking process, that's the important part. And I would like to refer to some very good quotes. That we know solution to a given puzzle. It's hard to find another one. Which means that if you know that this is exactly what I need to do, this little narrow thing, I will miss everything outside that. As a tester, we know that we can't just expect us to know exactly where the defects are. We need to think wide to find our defects. So what is that? We don't know the solution. You don't know where the defects are to be found. It's so much easier to find your own solution. And that's what we want to do as testers. We want to keep our ideas fresh all the time. Those are words by a doctor in mathematics from Germany, Rainer Knizia. I think they're very good for testers as well. So, what do you do then to encourage creative thinking? How can we do that? There are a number of characteristics that a training session should have to really make people learn in an efficient way. One of them is motivation. We want the students to be motivated. They should have fun during the training. That will help them certainly to remember things and really put effort into training. We want to broaden the context. Rather than just feeding them with meaningless words, we need to put them into context of why they are used. What is acceptance test? It's part of a longer testing cycle, yes. It's part of a bigger project. It has a certain objective. That's the kind of context we want to capture for our students to help them understand what they are learning. We need to make things concrete as well. Not just throw out abstract, fluffy words, but give them a true meaning. A good example of those things are when you are given a case study. You have this nice theory. You're given a case with certain context. You need to apply your theory. It gives you context. It makes very concrete what you're doing. We need to have it as a social context. It's so much more fun to learn together than on your own. Of course, we need to have an environment, a setting that encourages students to ask questions and get good answers. I mean, all this cliché about no stupid questions, only stupid answers, it is true in this case. I mean, I had a teacher once who answered a question with a very nasty answer, and I think that student never again asked any questions. We don't want that. We want to really encourage students to ask questions. Feedback is very important, and I'm not talking about feedback as answers. It was the previous one. This is feedback on what you're doing. Is it good? Is it bad? Could you do it better? You will learn that when you work, but even better if you can learn that while training in a safe environment. Rewards, very important too. When you have succeeded in something, you should be rewarded as well. Do you know what I just did? Besides briefing. I described the perfect condition for a good game. This is what modern games are like right now. They are hopefully fun and motivating. They give the players a context for their actions. You don't just play mindlessly, you play because there's a certain context that you try to achieve something. They make those very abstract concepts a bit more concrete. We cannot gamify real-life things to make them easier to grasp. Social, of course, to play with other people. That's why I like board games and not computer games, because computer games you often, but not always, play on your own. Board games are very social. They encourage players to ask questions about what happens if I do this, if I do this, if I do this. And they will get feedback on what they do. You do something, you score something, or maybe you get worse score. And of course, reward afterwards when you win the game. So, how should we then try to turn testing, or first I should ask you, does this make sense? Or do you think I'm over-glorifying games now? We can actually look at some real-life examples. Because I claim that games have always represented life in some way. I mean, let's look at this. It's the beginning of civilization, agriculture. And looking at this game, Mancala. If you heard about it, but Mancala also means the sowing game. You take up some marbles in your hand, you drop them, you sow in holes, and you harvest them again. That's the representation of the ancient old way of sowing agriculture. We have, of course, also, in more military fashion, it's said that the old Chinese warlords, they planned their military campaigns. They actually invented the game of Go, an ancient game we tried to enclose areas. There's another story also that says that the game of Go was invented by an emperor who wanted to teach his son some discipline. So you can choose which story is most fun. Okay, how about testing them? Can we represent test in a game in some good way? Let's see what we can do. Oh, sorry, I forgot this part as well. This is a good one. This is a way to take programming into game. Do you know that game? Some of you do. That was invented by a Google employee to teach his kids programming. What you do basically is that you have certain goals on the board. You need to move this little turtle to crystals by playing programming cards. Go left, turn around, go right 2 steps, etc. And kids just love this. He raised like over $600,000 on Kickstarter and sold like 25,000 games to parents who teach their kids programming. Another example is a more complicated game, Kanban. Kanban, some of you know, as a methodology to work more efficient, and this game tries to use that in a car factory to work more professional and efficient. So now over to testing and see how we can gamify tests in a good way. Let's see. Oh no, stop. I just told you that. We should not listen to that. This is not a good game, right? So we should ignore that, forget that we saw that, and should move on to what we talked about in the beginning. Let's first again listen to my friend, Dr. Rainer Knizia. He said that it's not the goal that is important. It's the goal that's important, not the winning. It's wrong. What does he mean by that? It's the goal that's important, it's not the winning. What he meant is that when we play a game, yes, we want to win, but if it's just a matter of winning the game, we can just roll a die and have it over. That's not the interesting part. What we really want to do is we want to work towards a goal, feel that we accomplish the goal in a good way, and the winning is just a bonus afterwards. We had fun, try to reach our goal. That's the part, the objective of the game. So, let's go back to our questions in the beginning to make testing into a game. We need to put it somehow so the players is in a testing role. We need to give you a testing goal as well. We also need to give you some testing challenges, because it's difficult to be a tester, right? And we need to give you some meaningful testing decisions to make you feel that you're actually accomplishing something. You are being a good tester by having a role, goals, challenges, and decisions. By the way, maybe you guessed it already, but this is my friend, Rainer Knizia. He's one of the world's most famous game designers. No surprise, perhaps. So, let's look down into the game. Testing role. We're now going to build a game together. We need a tester. So let's just have it like a small gaming piece. We need some kind of test environment. So let's invent the game board. So far, so good. That was the goal. We need to find bugs. Say we have some hidden bugs on this board. We need to find them. That's our goal in this game. But should we just place testers all over the board until we find the bug? That's perhaps not very challenging, not very interesting decision-wise. So we need to move a bit further in this game design. We need a testing challenge. Say that we want to have a limited number of testers. I mean, that's what we have in real life as well. We can't test everything. So we need to have that in this game too. So yeah, we have few testers. You can just try to put them out randomly, and if you're lucky, you find a bug. A bit better, but still, are we using luck when we test? Is that how we find bugs? Anyone here rely on luck to find bugs? No. We need some kind of testing decision as well. What if we knew which areas are more susceptible for having defects? They are more defect dense. If we knew that, say, this row here contains more bugs, and that this column also contains more bugs, then we could place our tester here and find the bugs in just 3 attempts. So now we're getting somewhere in this game to try to actually provide some good testing decisions as well. Let's just recap on those decisions that we have. This tester needs to think about how to allocate time between analysis, find out which areas are more likely to have bugs, between testing, actually try to find the bugs, and also retest if they want to introduce a mechanism for new bugs into the game. You need to think about how much testing should you do when it's not worth the effort anymore. When we can't test forever, we need to say sometime that, okay, now we find quite a lot of bugs. If we continue testing, we might find a few more bugs, but they're not going to be critical, so we should stop testing now. We need to identify which areas have high severity and complexity, classical risk-based testing approach. And we can also see when the system is mature enough for test automation, which typically is when the most defects have been removed, then we start automate test cases and rerun them in our retesting. Not too bad for a simple board game. Of course, you don't learn all those things into detail. That's not the purpose of the board game, but you get the awareness of it. You start actually get this thinking process started. And using this together with education would, of course, make it much easier to have something concrete to discuss when you try to go deeper into testing. So, to summarize, we do have a testing game. It's actually done printed. We did it like this, use it. Of course, with all our testers available, and even some bugs as well. Just to make it a bit more fun to actually use it for real. In this game, we see a planning phase with a clear learning objective. They analyze the board for this defect density. They do some risk-based testing, do some test and retest, and afterwards we can discuss our learnings. So we have this very basic test approach that you find in ICQB, translated into this board game. We have a lot to discuss afterwards. Anyone more into Agile testing? Yeah, some of you are. We can make a game of that as well, of course. This is still in design phase, so to say. Board games also have this project life cycle. But I can show you some ideas what it should look like. Testing row, Scrum Master, of course. And again, our computer system is simplified into small components. There are going to be many of them that take some input codes represented by small cubes and output codes. The testing goal would simply be to implement user stories. So the players take turn to plan for user stories. So called as a player, I want input. In this case, a red and a blue cube is a secret user story. And it should produce those cubes. So very simple way to just make coding and testing abstract. So the challenge of this game will be, for me as a tester, I know that there's a secret combination giving me a yellow and green cube. So I can just plan my coding to get the cubes I need, start guessing work, and play cubes and see if I pass the test or not, which is what we call test-driven development. You have your test case, you test until the test either passes or it fails and you continue to testing. testing decisions then would be to complete those small components that fit together, red fits red, etc. And you build a bigger system out of those components. To give you some discussion ground for how to test in an agile environment setting. Again, very simple, just to get the thinking process started, but then we will have somewhat more concrete to discuss. So let's see how we have, which decisions we have here. We get to learn how new stories are created. We get to discuss a bit about how you manage code repositories. You see the cooperation between testers and developers. And I get to think a bit about the continuous integration. So some classical agile test concepts put into a small game. Just to summarize them, we see this typical agile test process life cycle. You have a backlog, you iterate, the test design, development, test execution, and then move into sprint backlog and continuously integrate the components that you're developing. Some examples then of how we've been using this at SQS in Sweden. It can be used, for example, at fairs like this. We put up the game, it attracts people, play it with them, and get them interested into what we're doing, and see our creative way actually looking to test. Of course, used also in social events. Back at the office, in this picture taken, we play the games and compete against each other. We also use it actually in interviews, just to see how people react when they're put into this kind of testing challenge. Now, we know a bit more about how to think like testers. We have some ideas about what processes we're going through. It's now time to see how we can move our knowledge to the next level. I mean, we start with general skills from school. We have a very general concepts of how things are working. As we study on higher level and start working, we develop our special skills. But it's not until we have experience that we really become experts of things. And obviously, you can't teach experience just like that. You need to work to get experience. But we can help you on the way by actually giving you good training. And that's what I'm going to cover now, how we get this good training using the concepts we just got from games like Find the Bug. So let's connect it then. We have the basic test process: plan, analyze, design, execute, close, fresh from ICQB. We put on that what you just learned about how to create a good learning environment using game concepts, motivation, context, make it concrete, social, questions and answers, feedback and rewards. This is the environment we want to create. So let's now see step by step how we do this. The planning phase. Why do we plan testing? Just because the project manager wants a test plan? Yeah, sometimes maybe, but we want to do planning also to help us be prepared for what happens afterwards. So when we do the planning, we need to think all the way through how we're going to use it. Why? So the first part is we let the students gather information for interviews. This is important for a test lead, because on a project there can be a lot of information. You need to find what you need right now for your part in the project. So that's what to practice, and the teachers will play stakeholders. So they come to us and ask, I would like to interview, say, the customer manager or the project manager or whatever. And we role play this out. And if they do well in this little role-playing game, we're rewarded with some artifacts, just some simple documents you can use to continue building the test plan. And if the test plan is good, what do you do with a good test plan? It keeps you prepared for whatever can happen in the project. So if it is good, we give them more rewards. We give them mitigation cards, let's say. Because they tell you that I had a good plan, so I'm prepared to mitigate whatever happens afterwards in the project. That's how we reward our students in a game fashion. Let's look at some samples. Artifacts could be, for example, just a small process flow or maybe a requirement list. Typical testing documents that you get. We also provide those with those small mitigation cards. You did cover metrics in your test plan. Here's a card. You did cover enter and exit criteria in your test plan. Here's another card that you can use to play later on in the game. And with that, we close the planning phase of the education and move on to the analysis phase. It's important to use all those artifacts to analyze what is this testing challenge that we have right now. What do we need to test? Where are the risks, etc. This is how you really get to use your creativity in the training. So using artifacts, you can, for example, look into the risks. This is an area where I think we would find many bugs. We should prioritize this. Here's something you should try to capture in the plan, etc. To do this risk-based testing. Also, it would help you set up a test schedule. Because you know all the parts of the system that you need to test. Now it's up to you as a test lead to allocate your testing resources wisely. Moving on to the design phase. Again, we look at these artifacts and try to think, where does this testing need that we analyzed before, where does it fit in the project? Should it maybe be part of a system test or integration test? That's things that students would come up here and be rewarded for, if they come with good answers. They will also choose a good test method for certain challenges. Again, using all those concepts we have from ICQB, but on real-life cases. And finally, then write good test cases. The reward from this part is that they get a certain test hour budget, so to say, so that they can work with in the final execution phase. This is the part of the testing that we really like to be in as test leads. Finally, after all planning, the analyzing, the designing, we get to do the testing. So use your test hours, you allocate them to the system, very much like you do in a simple board game, but the board game is here represented by a computer program that tells you the result when you do the testing. You can also, if something happens in the project, play your mitigation cards. There's a risk here that you didn't think of. Sorry, you're losing one testing day or whatever, unless you had a plan for it and can mitigate it with the cards. And the end result is that you find bugs that will determine how well you did your testing. Let's look at some examples again. Say that you have 200 hours. You allocate them to certain areas of the testing. We throw in an unexpected event. It always happens things when you do the testing. But of course, we always prepare for everything as good test leads. In this case, say that the integration failed unexpectedly. It means that you can't test this until much later in the project. But maybe you could throw in a mitigation card, and you don't have to worry about this because you were prepared for that. So that's how we play out this test design, test execution phase in a good way. It means that you can continue testing without being interrupted, and in the end, we get a bug result fed out from this little application. In this way, we have kind of recreated the challenges of the test lead from the planning phase or through to design phase. We can conclude them with a close phase. We get the students to produce the test results in a good way, so the stakeholders understand what the testing conclusion is. A good test presentation, very important, because as test leads, this is your finest hour really. Throughout the project, everyone's working very hard, but this is where all eyes of the project are upon you as test leads to present the results. So in our training, we actually bring in our highest managers to listen to this presentation, to really make the students feel like they're important, someone's here to listen to them, and this is what they have to say. Of course, we also have lessons learned afterwards, important in test projects, and of course in training as well. We try to capture what students felt about the training, what lessons they learned, and what we should bring on to improve for the next time we take the same training. So, try to summarize this. We've seen testification, so to say. We move from a game, take a simple board game, and make it into a game with testing challenges. We've also seen gamification. We take the test process in a test case and turn it into a game to facilitate the learning process. We looked into how important it is that in the training we provide students with a clear role, a clear goal, and some challenges and decisions to overcome those challenges within the game. We've also seen how it's important that you, in this learning context, improve and strengthen the training with providing a fun and motivational setting for the training. A context that puts everything you learn in a real-life context so you understand the purpose of what you're trying to teach them. We make things concrete. We turn abstract things into very concrete things, like this is what you do hands-on, to help them understand that. It's going to be a social event, it's very important. You do something together. As a tester, you work in a big team, and as a student, you should also work in a big team and have fun together. You should welcome their questions and give them good answers, and you should make sure they get feedback on what they should do in the training. And some kind of good reward afterwards. It's very important to see that, yes, I got a bit better after the training. Yeah. All that will help you to think like a tester. Our overall objective of the training. And with that, I would like to thank you for your attention and open the floor for questions.